Dear colleagues, dear friends, needless to say that I would very much loved having the opportunity to join you in this traditional conference in Belgrade, but we live in troubled times, and it is for this purpose and for this reason that I would like to share with you via this recorded presentation some thoughts which we have elaborated together with colleagues from the Ho Chi Minh City University and from the University of Split on the decarbonization strategies for commercial buildings. We are all quite aware of the fact that global energy demand is expected to increase rapidly in the coming decades. According to predictions, it will increase by almost 50% in the next 30 years or so. And this is of particular importance given the fact that despite the progress in the penetration of renewables, fossil fuels still remain the basic source of our energy. As if this would not be enough, for a variety of reasons we are now amidst an energy crisis, with gas prices increasing by more than 300% in a year's time. And we all know what this means for our economies and for our economic growth. In this line of approach, rational use of energy and energy conservation do remain the most cost-effective energy sources that we still have available. Now, the commercial buildings account for a quite significant share of the final energy demand all over the world. From 4% in Asia to 20%, almost 20% in the States, commercial buildings consume vast amounts of energy. According to researchers in the European Union, malls consume on average close to 500 kilowatt hours per square meter a year, whilst in the United States this is more than 600. So they are happy energy eaters, and we do have to take care of those if we want to reduce energy expenses and also obviously also our carbon footprint on the environment. If we want to approach the decarbonization of commercial buildings, the strategy that we have is pretty much straightforward. We have to reduce the heating and cooling requirements of the buildings. We have to improve the efficiency of the heating, ventilation and air conditioning. We also have to reduce electrical requirements, which are quite high in those buildings, lighting, plug loads, equipment and so on and so forth. And finally, then we can utilize renewable energy sources. I believe that everyone will agree that it makes little sense to start, for example, with the renewable energy sources if we have not reduced the requirements or if we have not improved our efficiency before. Now, due to the progress in the technology and in the research and in the manufacturing, we have a bundle of tools available to achieve this goal. It starts with advanced materials like state-of-the-art insulation materials, super insulating materials, cool materials, smart glazings. We have excellent HVAC systems, which are in the epicenter of the KYRIAKia conference, from high-efficiency boilers to high-efficiency chillers, heat pumps, cogeneration. Then, of course, one of the most important fields of development over the last years are automation and controls, sensoring, adaptive controls, predictive controls, everything that can help us and have a more flexible and even a more smart operation of the buildings. Similarly, one cannot fail to notice the advance in renewables. One only has to think of state-of-the-art photovoltaics or of concentrating solar systems for power generation, or even of ground source heat pumps that enable us to cover significant parts of the heating and cooling loads. We have also integrated components like smart facades that enable at the same time a very nice degree of natural lighting, at the same time having sun protection and that respond to the changes in weather conditions and the operational requirements, and so on and so forth. So the question is, if we have all the tools and if we know the strategy, why don't we proceed faster with the energy renovation and the low carbon refurbishment of the buildings? And one of the obstacles we have to face is that we need to adapt the refurbishment strategies to the operational patterns of the buildings, because commercial buildings have a high utilization factor. They are very valuable assets. So we have to differentiate, let's say, at 5 levels of refurbishment. starting from the very plain traditional maintenance, where one can carry out maintenance and slight upgrades of the HVAC systems without having an impact on the operation of the building and on the tenants, and that can last a few days, to the very other end of the measures, which include deep renovation strategies where you strip back the building to the basic structure, remove all the facade elements, replace the HVAC systems, which is of course something where you have to have the building for 1 to 2 years out of use. You require a lot of licenses, approvals for a new project, and so on and so forth. And in between you have anything from minimal to major refurbishment interventions that can affect the building's operation for some days to a few months. So we have to consider what the goal of our refurbishment is and for how long we can have a building being under repair, under refurbishment, so that the investors have a clear picture of what lies ahead. Now, if we come back to the technological aspects, it is quite interesting to notice, for example, that over the last 10 or 20 years, thermal insulation has experienced a silent but very important progression. So we have thermal insulation materials that nowadays have excellent thermal conductivity values, very low lambda values. In the case of the super insulation materials, they are an order of a magnitude smaller than traditional insulation materials are. But what is also more important is that we have, for example, structural insulated panels as prefabricated tools that can be used to replace building elements at a very high pace and with very high efficiency. Or of course that we can also, for smaller interventions, apply polycyanurate forms in situ, covering architecturally difficult shapes and without exposing the building to any important interruption of its operations. Perhaps one of the most important fields that where advance has been made over the last 10 or 15 years are cool materials. And particularly if we think of the Mediterranean region, or perhaps of the Middle East or Northern Africa region, the necessity to reduce peak surface temperatures during summer is very important, because this can lead to temperature drops of, let's say, 3 to 4 to 5 or even 7 degrees Celsius beneath the roof, and this has a severe impact on the air conditioning loads. And those are tools or materials that can be applied very easily without interrupting the building's operation. Something which is also important to notice is that cool materials in forms of paints or emulsions are very interesting also when it comes to covering exposed HVAC equipment like ducts, so that you don't lose energy which you have very costly produced a few minutes ago. Commercial buildings, at least some of them, have also very extended glazed areas. And we have established for the last 20 years now the use of low emissivity glazings that are very nice in order to reduce thermal loads either from within or from without. But we have moved a few steps ahead. So we have now photochromic glazings which adapt passively to the variation of the solar radiation during the day, and so that you can reduce the heat being transmitted and hence the cooling loads as a correlation to the solar radiation. And of course we have moved ahead to, let's say, electrochromic glazings, where you can actively steer the transmissivity to the glazing so that you control the interior, both considering the lighting quality and also of course the cooling loads in a much more advanced and sophisticated way. Cost factors are still interesting. I mean, low E glazings are competitive to conventional glazing. Photochromic glazings are still slightly more expensive. Electrochromic glazings are still to come, and they are very expensive, and there are some matters of functionality, but it is certainly one of the key steps for the coming years that will help us in reducing cooling loads. One tool that is quite interesting, because it does not only affect the building but the whole urban environment, are green roofs. And this has been highlighted since the 90s and the first major heat waves recorded in urban areas, that being able to mitigate the urban heat island effect locally, or even if you plan a major action on the city level, on neighborhood level, is quite interesting. Green roofs are a very nice architectural tool to establish also some spaces of living and of having a useful break, and even for educational purposes. They can contribute to the reduction of cooling loads, let's say, but by anything between 2 and 10%, depending on the building type, on its use, and on the climate condition. On the other hand, one should keep in mind that when refurbishing existing buildings, you add some weight, and this has to be investigated before. And of course, that you have also a water balance, which in areas like the Eastern Mediterranean is always a critical matter, because it is not really a very purposeful exercise to reduce energy consumption, but to have a high demand of energy water, which can be sparse and precious over the summertime in many parts of the world. Now, if we come back to think of the way in which commercial buildings are traditionally cooled and heated and hot water is provided, we have to adopt an approach that really tries to integrate the various technologies existing. We have wonderful heat pumps today with coefficients of performance that would be a dream 20 years ago. We have also excellent renewable energy systems for on-site power generation, from PVs to CHP, even to micro wind generators. What is crucial and what has to be part of such a strategy is that this has all to be integrated. So we have to make strategic choices. Let's say if we go for an all-electric approach, we need PVs, or we need micro wind, or we need even CHP to drive the heat pumps, which can provide for cooling and heating, eventually for hot water. Or if we want to go towards a more thermal approach, then we would have to use some high efficiency CHP, or perhaps some use of biomass fired systems if it is allowed by environmental regulations. Or even we can use the traditional established well-known and reliable solar thermal systems. But more important than choosing a high-end, highly efficient technology is choosing a strategy that includes all the process from energy generation to thermal energy deliverance and to the overall performance of the building. So this is one of the topics where we really need interdisciplinary work together with the architects, together with the civil engineers, and of course us mechanical engineers, who will contribute our part to choosing the most effective and most efficient system that serves the specific building with its features that can differ from other similar buildings. Let me give an example that's already 15 years old. It's an office building that was refurbished. It's in Athens, in Greece, and it houses a company that produces solar systems, by coincidence, where we tried, together with other laboratories and the company housed there, to come up with a nearly zero energy building in the heart of a city, in a building that is very conventional, hence with no architectural extravaganzas. And so we came up with combining solar thermal systems, flat plate collectors, Fresnel collectors, geothermal energy by means of a ground source heat exchanger, and using absorption cooling to meet the biggest part of the air conditioning loads of the building. Furthermore, there were some photovoltaics, which can be seen on the left side of the building. It is vertical, it's not exactly southern oriented, but it's still there. And what is more interesting is that the building also features thermal storage options in terms of concrete tanks in the ground, so that you can store excess heat produced mostly by the solar systems to use it outside the hours when you have the solar radiation available, or you can even use it in the winter to reload the ground so that you don't face problems with depletion of the ground energy after 5 or 10 years of operation. We have been monitoring this building ever since it was constructed, and overall it achieved a solar fraction of close to 70%, which is not bad for a building not on purpose designed to be a zero energy building. And most important, it has been proven to be a very reliable set of systems working well together. Now, this is not enough anymore. Making a building that is efficient, that is even resilient in terms of energy supply, is not enough if we don't integrate it with the energy infrastructure. And the more the renewables progress in the network, the more it becomes important to integrate the building into the grid. So we have to be able to shave loads, the peaks of the loads. We have to be able to transpose loads during off-peak hours, and we even have to be able to allow a bidirectional communication, i.e. feeding the grid with energy produced in the building or receiving energy from the grid, supporting electric vehicles, and all these nice things that lie ahead in the future. So the buildings have to be integrated in an active way, in a proactive way, in the energy grid. Smart sensoring, smart metering, all this can be utilized to make buildings that are really part of a big integrated energy system. And at least in my opinion, this is one of the true prerequisites if we want to decarbonize our cities in the coming years. Now, I believe that we agree that there is indeed a necessity for an integral strategy for the refurbishment. And we will not be able to achieve zero energy goals or nearly zero energy goals without some high-end strategies, i.e. Smart buildings, energy storage, concentrated power generation, or similarly. But we have to keep in mind, we should not forget that these high-end strategies and these advanced technologies have to be integrated with well-known and proven measures to improve the buildings, in that case the commercial buildings, energy efficiency. And in that sense, we must always keep in mind that we have the HVAC systems, we have the building envelope, we have the lighting, of course, and we have all this working together smoothly, neatly, without timely or spatial contradictions, in order to be able to fully utilize the renewables. One more thing, it doesn't really make a sense to try to make a low energy and low carbon building if we cannot measure the impact of decarbonization, because we have to be able to convince A, the building owner and the stakeholders, and B, also obviously the regulatory authority, the state, that the carbon footprint has been reduced. For this purpose, we can use the tools of carbon footprint analysis, we can use life cycle analysis, or of course we can use the well-known environmental rating systems like the BREEAM, the LEED, and so on and so forth. But in order to demonstrate that what we plan and what we implement is really successful, and we can also be able to be monitoring this after the refurbishment has taken place. One point that has to be underlined is that we have to choose the appropriate indicators, which in the case of commercial buildings may, for example, be kilograms of carbon dioxide equivalent emitted per square meter, but they could also be kilograms of carbon dioxide equivalent with respect to the customers served, if it is hotel, to the overnight stayings of people, because this is the only way in which we can carry out a benchmarking exercise that is not only formally correct, but that is also substantial and convincing. Commercial buildings are complicated buildings. It isn't always necessary, or it isn't always most efficient to use, for example, the heated area as a measure of energy consumption. In some cases, it can be the turnover, or it can be the people that they serve. So this has to be chosen on a project-by-project basis, and this has to be done in a way in which we can produce convincing results. In this line of approach, and in order to sum up my conclusions, I would like to highlight a few points. Decarbonization of commercial buildings is a huge challenge, but it is at the same time a great opportunity. Commercial buildings are complex, they have varying requirements, they have also often contradictory priorities on behalf of the developers. High levels of lighting that are not really compatible with high energy efficiency, for example. Owners and managers don't always agree on the goals. Managers, per definition, tend to reduce operational costs. Owners would like to have a maximization of the assets' value. And so this has to be treated in a respectively complex way. On the other hand, they present a challenge because they are significant, they are capital-intensive investments. They are precisely for these reasons be evaluated by different criteria by the stakeholders. And of course, also they are landmarks in our cities, and so they can present the best examples that we can in order to promote energy efficiency and decarbonization. I think we can all agree, and we are all experts in these fields, that the expertise and the technology to achieve low carbon refurbishment is there. It is available. We have it. We discussed briefly during these presentations various of those tools like insulation, cool materials, and so on and so forth, which if we use it wisely, and if we combine it in an effective way, they can reduce energy demand and emissions by a factor of 2. And this is something which during a refurbishment process is really not a small achievement. I believe that what is really needed in order to foster the decarbonization of commercial buildings is an integrated strategy. A strategy that will work out against the background of assessing not only the decarbonization's immediate return on investment, but it will also consider the building's impact over its life cycle, even if this is not 50 years, but it can only be 20 years. And hence, it will be a way in which one can include the corporate social responsibility approach, which is becoming more and more important. One only has to think of the sustainability indicators that most listed companies nowadays have to present in order to be appealing to their shareholders. And so it can become a goal of a productive, yet at the same time sustainable low carbon economy. I would really like to thank you for your attention. I hope that next year we will be able to meet in person. If you have any questions or any comments, please feel free to email us. Thank you very much for your attention, and I wish you all the best.